In this video, I'm going to talk about sound waves and tubes. I'm going to talk about a closed tube in this example here. So I'm going to draw a closed tube here. This is the open side, and this is the closed side. So this might be like the test tube we had in class, or it might be a drum. So if I draw a drum sideways, this is the side you hit, and this is the open end. So if you recall, a closed tube is a quarter of a wavelength. So there's a quarter of a wave. I'm going to extend this out a little further here so we can draw a complete wave. Here's 1/4 of it, and it goes down and back up, and there's your complete wave. So in the tube itself is only a quarter of a wave, this first part. Half, 3/4, and the rest of it. For this example, I'm going to say the frequency of sound that's produced is 20 hertz. And the question is to find the length of the tube. What is the length of the tube? So this distance here, L, what is the length of the tube? Right there. And one other fact we can use for this question is the speed of sound. We're going to use the value of 340 meters per second. You know that's a standard speed of sound. If you change altitude, air density, that number changes. But for standard problems we're doing in the class, it's 340 meters per second. That's the speed of sound. So how are we going to find L here given the information? So we're going to list some equations. So the equations we're going to list are, number one, speed is equal to wavelength times frequency, which we've seen before. And then in section 4, we've seen that we have a couple different equations here. For a closed tube, the wavelength is, as you can see above here, is 4 times L. So whatever wavelength we find, 4 times L, whatever wavelength we find, it's 4 times L. And just for completeness, we're not doing this here, but open is 2L. So these are on the equation sheet. Again, you don't have to memorize these. These are all there. We just have to know how to use them. So variables. What variables do we have? So speed. We have wavelength. We're going to use the closed version. Wavelength. I'll put a C for closed just for clarity. The frequency we do know is and L here. So what do we know? We know the speed is 340 meters per second. Let's write that down. 340 meters per second. The wavelength we do not know. The frequency we do know is 20 hertz. And the length of the tube is what we're trying to find, so we do not know. So if you box what you don't know, it should be numbered 1 in your homework. That should be labeled number 2, and this should be labeled number 3. Okay, so let's go to the solve part. So we want to find L, that's what we want to find, and it's the closed version here. So we need to find wavelength. So in order to find wavelength, then we need to go to this equation here because we know frequency and speed of sound. So it's a two-part type problem. Find the wavelength first. Once you know the wavelength of the closed tube, it's equal to 4L. So let's see, for the first part. Let's do the first part. So speed is equal to wavelength times frequency. So wavelength is equal to speed divided by frequency, which is 340 divided by 20, which is 17 meters. So this entire distance here, this entire wavelength, all the way across the entire wave is 17 meters. It's a pretty long wave, right across there, all the way across. So you can see in the diagram and the equation that the wavelength is equal to closed 4L. Therefore, L is equal to wavelength divided by 4. So that's the 17 and 1/4 of it, which is 4.25 meters. That's your answer. And just to make sure that makes some sense here, if this is 4.25, so 4.25 from here to here, then I have another 4.25 here, and then another 4.25 in this interval, and it's not drawn on a scale, another 4.25 there. So a quarter of a wave, quarter of a wave, quarter of a wave, quarter of a wave, 4.25 plus 4.25 plus 4.25 plus 4.25 gives you a full 17 meters. So these are steps you're going to use to solve for wavelength frequencies and lengths of tubes for sounds and tubes. Again, this is for a closed tube, 4L. If it were an open tube, it'd be 2L. These are on the equation sheet, so you just have to know which type of tube you're working with.